Alright, let's look at number 2 now. It reads tangent of x plus cotangent of x equals secant of x times cosecant of x. Okay, so first of all, you need to ask yourself, what side looks the most difficult? And in this case, most of y'all might say the right-hand side, but it actually is the left-hand side. And you'll start getting better at this the more you work these type of problems. So, let's look at the left-hand side. We have tangent of x plus cotangent of x. So the first thing that you need to do is put everything into terms of sine and cosine. Alright, so here we go. I'm only working with the left-hand side. That's not what I want. So if I change or rewrite my left-hand side, my first part I will get sine of x over cosine of x plus, and then cotangent can be rewritten as cosine of x over sine of x. Alright, we got that part? Okay, so now we have a fraction over here plus a fraction with different denominators. So what do you think we need to do? Correct, we need to find a common denominator. And in this case, our common denominator for both will simply be cosine of x times sine of x for the first part, plus, and I'll do the exact same denominator for the second part. Alright, so in this case, now we need to adjust the numerator. So remember, this is how I do it. This bottom divided by this first bottom, right here, which is cosine of x, what cancels out? Your cosines, correct. What are you left with? You're left with sine of x. Multiply what you're left with times the numerator of the first part, which is sine of x. So what is sine of x times sine of x? Correct. You get sine squared of x. Let me erase this part right here. Fix that. So we get sine squared of x. Alright, now let's look at our second part. Our second part, the bottom is cosine of x, sine of x. If we divide that by sine of x over here, what are we left with? We're left with cosine of x. Now what is cosine of x times cosine of x? Cosine squared of x, correct. So we have cosine squared of x. Alright, well now that they have same denominators, what can we do with fractions with like denominators? We can simply combine them. So when we combine them, we get sine squared of x plus cosine squared of x all over the exact same denominator, cosine of x, sine of x. Alright, let's look at the top. We have sine squared of x plus cosine squared of x. If we remember our identities, and I provided some identities over here, these are your fundamental identities, which are most of the ones I introduced you to. You have this one right here, which says cosine squared of theta plus sine squared of theta equals 1. I probably gave it to you as sine squared of theta plus cosine squared of theta equals 1, but that's the exact same thing, because no matter how you add, you're going to get the same number. For example, 7 plus 3 is 10, and 3 plus 7 is 10. Alright, so now we know that this top part goes completely to what? 1. Correct. So let's go ahead and rewrite it and replace it with 1. So now we have 1 over cosine of x sine of x. Alright, we're almost done because now all you need to do is basically split up this fraction. And when you split up this fraction, you're going to get 1 over cosine of x times, let me find my dot for multiplication, where is it? Probably, we'll just use this one, times 1 over sine of x. Okay, so do you agree that if I multiply this fraction right here times this fraction right here, if I do top times top, I get 1, which is this number right here. And if I do bottom times bottom, I get cosine of x sine of x, which is this denominator right here. So I didn't do anything to my problem. Alright, so now we have 2 types of fractions. Well, you should know that the identity for 1 over cosine of x, let's check it out. 1 over cosine of theta is secant of theta. So in this case, it's going to be secant of x and then we know that 1 over sine of x, so let's check our identity. Over here it says 1 over sine of theta equals cosecant of theta. So in this case, we will have cosecant of x. Is this answer equivalent to what's supposed to be the answer from our original equation? I believe so. So our next part is to go ahead and conclude with the proper notation. So we will have therefore secant of x cosecant of x equals secant of x cosecant of x. Alright, any questions on that?